Hi there, and welcome to Physical Geology. We're going to have an amazing semester full of all sorts of geologic wonders of our world. We'll talk a lot about the materials that the Earth is made of and where all of those are found and how they're made and what they look like. We'll also spend some time talking about the processes that go on the surface that change our landscape and shape the world around us, including this beautiful shots of four peaks just outside of the Phoenix Valley. And we're also going to talk about some hazards. The Earth is a dangerous place, and we're going to talk about some of those things that are dangerous around us as well. So we have a broad swath of things we're going to be talking about throughout this entire semester. So, have you ever thought about geology? Like a geologist, what does a geologist even do? You know, our traditional idea of a geologist actually fits this picture pretty well. It's a dude, and he's got on his field gear and his hiking boots, and he's got a beard because they always do. And he's out banging on some rocks. Now, I actually know the guy that this cartoon is based off of, which cracks me up. And I like to remind him of what kind of poor field etiquette here is happening in the picture. You shouldn't be whacking on a rock with a rock hammer while you're holding it. Put that thing on the ground. You know, so a lot of people think about geologists as these people that wander around outside and pick up rocks, right? But you know, there's a whole lot more to it, and a whole lot more to the way that we study the Earth. So these are some pictures of geologists that are hard at work, and sometimes, they're out looking at rocks and picking up rocks and taking measurements. But in other cases, they're doing all sorts of really cool stuff too. The top left image, they are measuring stream flow and what looks like to be a kind of a small stream. A lot of geologists do study water and how water flows and how it changes. So hydrology is an earth science just like geology is, and a lot of hydrologists have really strong geology backgrounds. At the top middle, we have someone who is studying some geologic core samples. So you can drill these awesome core samples right out of the ground and take a really nice long cross-section of the Earth below us that's usually not visible. On the right, there's a volcanologist doing some testing on lava, trying to stay kind of cool there. Below it, that's actually a geologist too. This is Jess Phoenix. She is a volcanologist who lives in Southern California, but she ran for U.S. Congress. She didn't win, but geologists are even politicians. And when you think about it, you know, it's a super important science, and understanding how our Earth works is really important to making really important decisions at the highest levels of government. And it was nice seeing her try to get there. Right next to her is a couple of volcanologists doing a little bit different work. They're actually sampling gases that are being released by a volcano. I believe that's Mount St. Helens, like in 1980, but I could be wrong. Next to them is a geologist working on what looks like maybe an iPad or some sort of tablet, and standing up on a cliff with a beautiful view. So there is hiking that can be done. There's a underwater submersible next to that person. There's a huge amount that we don't know about our ocean, about the ocean floor, and about the processes that go on there. And so it's a great frontier that we still need to learn a lot about. Below that are some students who are measuring rock outcrops. You're going to get a little taste of this as we get about halfway through the semester. In the middle bottom, those are seismologists. They're actually setting up some seismology equipment there. And they're going to measure some small shaking. And I think they're also got a GPS unit to measure movement of the surface. Now, these last two pictures are the same person. This is Dr. Wendy Bohan. Dr. Wendy is a earthquake geologist, and you can see kind of both of her images once she's at work. On the left, she's doing field work that may have been in Tibet, but she did a lot of researching faults and all over the world to understand how earthquakes work. On the right is actually a picture of her in one of her appearances on TV. She's a science communicator, and that's what she does more than anything at this point. And so you can catch her on kids' science shows. After a big earthquake, you can catch her on all sorts of news coverage. It's pretty awesome. So she wears a couple of hats in her role as a geologist, right? And while some of them are picking up rocks and studying rocks, this doesn't even include the people working in labs or the people who sit in front of a computer and write code. Sometimes that's what a geologist does. So basically, any sort of interest that you may have, all the way from writing codes to do computer modeling using supercomputers and big data, because there are geologists do that, to going out and mapping where rocks are or hanging out on an active volcano, but also into even art. I know NASA is actually they tend to hire a lot of artists to help depict the things they're finding and learning about in the surface of other planets and a lot of our planets too. So even art and photography, that stuff gets pulled into geology as well. So what is geology then? Because I just talked about a lot of things. So geology, if you want to break down the word origin, it's the study. That's the ology, right? And geo is earth, the study of earth. And that's a little broad. But it is a part of earth science. So the earth sciences all study the earth. And here in geology, we tend to lean more towards mostly studying the rocky surface and the processes that are going on right at the surface and beneath it. But other earth scientists include geomorphology or geographers that study not just where things are, but where people are and cultures are. There are meteorologists, there are oceanographers. These are all subsets of this big earth science. Now, when I talk about geology, though, it's not just the study of earth. It's the study of any sort of solid body that we can find throughout our entire universe. So on the left is a nice snowy picture from Bryce Canyon National Park. I actually took this photo. It was a couple days before Christmas, and it had been snowing, and there were maybe like 4 or 5 other cars in the whole park. It was amazing. But Bryce Canyon is known for its geology and those beautiful hoodoos and spires you see there in the pictures. On the right, it's a little bit further from here in the Phoenix Valley. This is the Eberswald Delta on Mars. Now, Delta has some air quotes there around it because that is just an interpretation at this point, but it sure does look like one. My background is actually in planetary geology. And so I tend to use a lot of examples from Mars and other planets too as we go through. So geology is not just the study of the Earth, but it's any sort of rocky or solid surface and the different processes that go along there on and under the surface. So this particular class is about physical geology. So this studies Earth's materials and the processes that operate within Earth and on its surface. And a lot of time this class is people's first introduction to geology in general. So it's a really nice, wide sort of survey of all sorts of geology, which is pretty cool. I want to make sure I identify some photos for you. The top left is one of the volcanoes of the Aleutian Islands. That's off of the string of islands off of Alaska. That is probably Mount Cleveland. You've got a rocky stream, looks like coming down out of a mountain, a beautiful set of moraines in a valley glacier, and a lovely amethyst crystal, looks like maybe on more quartz. So we'll be looking at all these processes and these materials. The picture on the right is actually from the Chiricahua National Monument. If you've never visited there, it's in like far southeast Arizona. It is one of my favorite places in the world. It's beautiful, and it's perfect when it starts heating up here in southern Arizona. It's nice and cool. Now, there are other studies within geology. So historical geology, we actually offer a class on this. Historical geology examines the origin and evolution of Earth, right? So if you're into dinosaurs, because who's not? But this also doesn't just include dinosaurs, but anything that has been living in the past. Everything from those big, scary megalodon sharks that have only went extinct in the last few million years, all the way down to grains of pollen from the very first land plants, which is pretty awesome. And then you could look at how the Earth and how its continents and how its atmosphere, how everything has changed over time. So we can understand what has happened in the past. We can make some guesses about what happens in the future. So this one is really cool because you apply everything you learn in physical geology. You just look at all those things and how that happened in the past, which is awesome. But there's lots of other fields too. I'm going to just mention a few of them, and I'm gonna introduce you to a few geologists who are actually studying geology right now and what they're doing at this moment, which is kind of awesome. So other fields of geology include geochemistry. So hopefully that sounds a little obvious, right? It's the chemistry of the Earth. And so this is Dr. Minnie Wadwa. She's actually a faculty at ASU, just down the road from us here. She used to be over the entire meteorite collection at ASU, and more recently, she's been the director of the School of Earth and Space Exploration at ASU. But she's a geochemist and a planetary scientist. So she applies what she can learn about chemistry to the entire solar system and the entire universe. So I've got some notes on what she does. Isotope analysis and chronometers. I know those are big words, right? But basically, she sort of looks at how our solar system formed, how planets and stuff came together. She also looks at water and what role that's played within the solar system, which is pretty cool. Now, geomorphology actually follows right down my interests. So when I decide to sound kind of smart, I'll tell people that I'm a planetary fluvial geomorphologist, right? So geomorphology, we've got that morph in there. That means shape. So morphology is the shape of the Earth. So what this does, it looks at landscapes and how they develop. How do mountains get shorter and valleys get shallower? That kind of stuff. So this is Dr. Nicole Gasparini. She actually did a postdoc at ASU back when I was there a very long time ago. So I've met her a couple times. She looks at landscapes and how they change over different scales. And actually, she teaches at Tulane. And her research group is the Giggle Group, which I absolutely love. She also does, and they do this with field work, actually going out and looking at the ground and taking measurements. They use remote sensing, so using satellites and aerial photography. And she's actually created a couple of really important computer models that can model and to predict how things could change in the future or what they look like in the past, which is pretty amazing. Geophysics, it's a physicist that works on the Earth. A lot of geophysicists look at the mantle of the Earth. A lot of them work in the petroleum industry because they study how things move under the surface. But this is Dr. Tanya Atwater, one of the most famous geophysicists in the whole world. She did some really important studies of plate tectonics. And really the things she did in her studies were why we could even understand plate tectonics as we do now. So she's played a key role in the development of geology as an entire science. Now, mineralogy actually studies minerals and how they form and how they develop. This is Rob Ulrich, and they are a biomineralogist, which is fascinating. They work on figuring out how crystals grow, but most importantly, crystals within living things, which is amazing. I just learned about them on the Ologies podcast. I don't know if you ever listened to that. It's amazing. But they were just on it as one of the guests who was in studies in ology, which is pretty cool. Now, everybody loves paleontology. Who doesn't love dinosaurs? But like I mentioned earlier, paleo goes a lot further than just dinosaurs. It's looking at any sort of life in the past. And there's some really neat and really weird things that have lived in the past. This is Dr. Matthew Downen, and they study fossil spiders. Hence the brooch there. And it's actually Dr. Downen has actually discovered like extinct spider species, which is amazing. And one of them, they named them after their mom. I don't know if I'd enjoy that much. So petrology looks at how rocks form and develop. Dr. Ping Ni is an experimental petrologist, which means he works in a lab. But he's trying to figure out how the Earth formed and changed into and developed its layers, like the crust, the mantle, and the core. So he gets to do a lot of playing with meteorites and other materials in a lab, which is pretty cool. Oh, there we go. Planetary geology. Like I said, this is my background. This is my jam here. It studies planetary rocky bodies other than the Earth. So this includes different planets. It includes moons of planets, especially those really cool rocky and icy moons around the big gas giants, which aren't as exciting. I mean, there's no solid rock, right? And meteorites and asteroids and comets and basically anything that's floating around out in space. So this is Dr. Phil Christensen. He is one of the most prominent planetary scientists in the world, and he is a professor at ASU. I got to take a couple classes from him, and I learned so much, and he's a really, really great instructor. But he has got his fingers all over our entire solar system. So he builds and designs robotic instruments. So he was the PI, or the primary investigator, of the thermal emission system. And that was on a satellite orbiting Mars. He built and ran the little bitty TESs that were on the Mars exploration rovers, Curiosity, Opportunity, and Spirit. And there's a lot of ands for him. He has a camera on Mars Odyssey. He has a camera on the OSIRIS-REx, which is going to meet a comet. Sorry, that was a big question mark. But he's also working on some planned missions to like Europa and around Jupiter and stuff. So yeah, he knows the Mars surface maybe better than anybody else. This is Dr. Rachel Bernard, and she is a structural geologist. So she looks at deformation processes, and we're going to do a whole section on structural stuff. But she looks at how the crust and the mantle move and change and bend and fold using rocks that came from there, which is awesome. And of course, there is volcanology. This is one of those people tend to really enjoy. Dr. Jasmine Scarlett is a historical and social volcanologist. So her family comes from the Caribbean, and in particular the island of St. Vincent, and it's had a history of active volcanoes. And she grew up hearing stories from her family and neighbors about these volcanic eruptions. And so she has studied how that's affected them as a culture and what that kind of memory of the volcano eruptions does to them now, plus what it's doing here in the future, because it started erupting again just in the last year, which is pretty cool. She also wrote a paper on how volcanoes are depicted in video games, which is very cool. And seismology, this is the study of earthquakes and how the ground moves. I already mentioned Dr. Wendy earlier, but she's an earthquake geologist and a science communicator. So she works for a big international consortium of seismologists, and she's based out of Washington, D.C., but she does a lot of their public communication and public outreach. So she is on the TV all the time. She sends out a lot of information. She's really pretty well known in terms of, geologists who talk about cool things on the internet. She's also part of an If Then initiative to help get girls and women into science, and she's part of the 500 Women Scientists. And that orange statue is actually a life-size statue of her that is on display as I'm recording this in Dallas. They did a 3D scan of a bunch of really amazing women scientists, and then they used a 3D printer and created statues of all of them. And so she's got a statue. Actually, it's the largest collection of statues of women that have ever been displayed anywhere in the world, in all of history. So this doesn't even cover all of it, because we can get into specifics of ocean geology or a rifting basin geology. And it's not as cut and dry as this sounds, because as a seismologist you tend to work a lot with structural geologists, because faults that move are part of that structure, and you're looking at the same forces that are creating those, and that gets tied up in geophysics. But geochemists work with petrologists, and they work with mineralogists, and they work with geophysicists to understand how minerals and the rocks, how they move and change and what they look like. So it's a really wide field, which means we study a lot of different cool things in geology, but it's also really collaborative. You get a team of all sorts of different types of geologists together to really understand the heart of what you're trying to answer. And I know it might sound kind of silly, but when people come to take geology as a college class, you're usually taking it because you don't want to go take chemistry or physics because there's a lot of math, and maybe you don't like squishy stuff, so you don't want to take biology. So people can sort of just fall into our geology classes and come in and thinking, I'm going to learn about rocks, it's going to be awesome. But geology is actually a pretty tough thing to study, because in order to really study the earth and its processes, you have to understand the chemistry. You have to understand the physics. You have to know the biology, all those other sciences. You have to understand those and have a really good knowledge of those to understand the earth. However, you can be a chemist and you don't need to know about rocks. You can be a physicist and you don't need to know about, how the mantle transfers heat. But it doesn't quite go the other way. So you need a lot of background knowledge to really do a great job. And all of these geologists I've been showing you here have backgrounds in physics and in chemistry and biology. So a lot of even mathematicians and computer programmers end up in geology. So I hope this is giving you a little look at what geology studies. We're also, in the next video, we're going to talk about, what a geologist actually does when they go out to, quote unquote, do science.